Hello friends, welcome to the course Essentials of Data Science with R Software 1, in which we are trying to understand the basic concepts of probability theory and statistical inference. So you can recall that in the last lecture we had introduced the concept of movements, and we had understood the meaning of first and second movements. The first movement is first raw movement actually, that is going to give us the information about the mean value or the central tendency of the data, and the second central movement, which is actually the variance, that is the central movement which is measured around the mean, that is going to give us an idea about the variation in the data. But those things we have computed in a theoretical framework. Right. Now, in case if you get a data, how are you going to compute these types of things, and how are you going to compute the movements in general? That is what is the objective of this lecture. So we are going to consider here that suppose you have got a set of data. I am not saying that the set of data means small or say large. When you are working in data science, the data science can be very huge, but that will be some finite number, right? And if you are working in some small samples, the data size might be say only 10, 20, 30 also. So in general, I will say that we have a data of size say small n, and based on that, how are you going to compute the movements and other types of measures, that we will try to see in this lecture, and we will try to implement it in the R software also. So let us begin our lecture. Okay, so now suppose we have a sample of data, and that sample is collected on a random variable x. For example, the x can be height, weight, age, etc. of our students in a class. So the observations on the variable are obtained as x1, x2, xn. So what is the meaning of x1, x2, xn? That means we have got here n observations, right? Suppose if I say x is my here weight, right? Suppose I take the first student and we find out the weight of the student. Suppose it comes out to be 45 kilogram. So the quickest way is going to be x1 is equal to 45. And similarly, if I try to take here second student, and suppose the age of second student comes out to be 50 kg, then x2 is going to be 50 kg, right? So and so on, you can get here and such values, right? Now, based on that, we are going to work how are we first going to define our movements that we defined earlier based on the probability function. So the rth sample movement of a variable x about any arbitrary point A based on the observation x1, x2, xn is defined at simply here 1 upon n, I goes from 1 to n, xi minus a raised to the power of here r, right. So this is how we will try to define it, where a is going to be some known value that we know, right. And in case if you try to choose here equal to 0, then the rth sample movement means the movement which I am trying to compute on the basis of given sample of data, right. That is called as raw movement, and it is defined here as a mu r prime, which will become here simply 1 upon n summation I goes from 1 to n xi raised to the power of here r, right, because you simply substitute here a equal to 0, right. And now even if you try to take here r equal to 0, then you see what happens. This will give you mu 0 prime is equal to 1, right. And in case if you try to take here r equal to 1, then what will it become? Mu 1 prime will become here 1 upon n summation I goes from 1 to n xi, which is nothing but your sample mean or the mean of the sample observation, right. So now in case if you try to define the central movements. So what are the central movements? the moments of a random variable x about the arithmetic mean x bar, they are called as central moment. Right. So, the Rth sample base central moment of the observation x1, x2, xn is defined as say mu r, right. And so, it is defined here as say 1 upon n summation I goes from 1 to n xi minus x bar raised to the power of here r. One point I would like to make it here clear that well, this is a quantity which is sample based, and means earlier what we had done, we had defined the mu r which was population based, right. So, ideally this symbol mu r which I am using here to indicate the Rth central moment, this should be something like m r or something. But in practice what I have observed that in data science and other applied statistician, they are using this mu symbol more often than say any other symbol mu 1 mu 2. They are although they are indicating officially the population value, but people are trying to use them as they are the values obtained from the sample. So, that is why intentionally I am not using here any other symbol, so that those people who are from this background, they may not get confused that I am trying to do something new. But this is the point where you have to be careful that ideally you must use here some other symbol which is indicating that the values are sample based, right. So, okay, so in this case you will see that in case if you try to take here r equal to 0, then mu 0 also comes out to be 1, and if you try to take here r equal to 1, then you can see here what is the value of mu 1, that will become here 1 upon n summation I goes from 1 to n xi minus x bar, and if you try to solve it, this will become here 1 upon n summation I goes from 1 to n xi minus x bar summation I goes from 1 to here n times here 1. So, this quantity is simply your n times x bar, and this quantity here is n times x bar. So, this entire quantity becomes 0, right. So, this is the very important result that you have to always remember, that the sum of the observations which are measured as the deviation from the arithmetic mean is always 0. That means, in case if you are given some observations x1, x2, xn, and in case if you try to transform them, that you try to find out their arithmetic mean and then try to define them, say x1 as x1 minus x bar, x2 as x2 minus x bar, and so on, xn as xn minus x bar, try to transform them, then the mean of these sets of new transformed observation will always be equal to 0, and that is a property which is very frequently used in statistics many times. Whenever we want to make the mean of certain variable to be 0, we always try to subtract the values of the random variable by its mean, right. And remember one thing, mu 1 is always equal to 0, whereas mu 1 prime is actually sample mean, right, sample arithmetic mean. Whereas, in case if you try to take here r equal to 2, then this mu 2 will become here simply 1 upon n summation I goes from 1 to n xi minus x bar whole square, which is the sample variance. So, sometimes people say that okay, mu 1 is mean and mu 2 is variance, which is not correct. Mu 1 prime is mean and mu 2 is the variance. That is trying to indicate the properties of central tendency and variation in the data. Right. Now, let us try to see how you can compute this variance and movements in the R software. So, in the R software, if you want to compute the variance for some given data vector here x, then the command here is simply VAR, and you have to write VAR inside the parenthesis, you have to write x. Well, one thing I can share with you, that whenever I am trying to use here the R commands, I am using them in the most simple format, assuming that all the observations are available to us and there is no issue. But this the variance command has many options also, that in case if some data is missing, then how to find it out, and there are many other things. So, my request will be today and for all the lectures, that I will be handling here the most simple case, because I want to make you understand. But once you understand, you must look into the help menu of the variance command or any command, and then try to see what are they trying to inform you. And you will see that when you try to use those options, they will be very helpful in data sciences, because in data sciences many times the observation, for example, are not available, they are missing. So, under those cases, this command variance of x will not actually work, will not give you the correct information. But if you try to use this variance commands with the possibility of excluding the missing observation, then possibly this is going to work, right. Okay, so one thing which I would like to emphasize here, that when you are trying to compute the variance using the command VAR in the R software, then this gives you the value of the variance which has a divisor n minus 1, right. So it is essentially computing 1 upon n minus 1, I goes from 1 to n, x I minus x bar whole square. And but whereas what you have learnt, that quantity has a divisor n, like as 1 upon n summation I goes from 1 to n x I minus x bar whole square. And the question comes that here, what is the difference between the two quantities? Well, in this lecture definitely I am going to talk about it, and here I can just share with you that this is related to the unbiasedness property of the estimator. This form which you are obtaining here, this is an unbiased estimator of population variance. But definitely as soon as I write this sentence, your mind takes 180-degree turn, that what is this unbiased and what is estimator, etc., etc. But I simply say, don't worry, just take my words here, and when I will be talking about the unbiased estimation, etc., then surely I will try to come back on this aspect and I will explain you, right. But surely, in case if you want to compute the quantity like 1 upon n summation I goes from 1 to n x I minus x bar whole square, then it is very simple. You simply try to multiply and divide this quantity by here n, and then you will see here that this will become here simply here is n minus 1 upon n into variance of x, where n can be obtained as the number of observation using the command length of x, length, right. So that is pretty simple. So, and then in case if you want to find out the standard deviation or standard error, whatever you want to call, but definitely the divisor is going to be n minus 1, then in that case you simply have to find out the square root of the variance, and for the square root, you know, the command is sqrt. And if you want to find out the standard deviation or standard error based on the divisor n, then you simply have to find out the square root of the variance that you have obtained here, right. As simple as that, very simple and straightforward concept. Now, let me try to show you that how are you going to do it on the R console. So, suppose there are 20 participants in an examination and who have got the marks out of 100, whose marks are reported here like this, and these marks are stored in the variable marks marks like this one. And suppose we try to find out the variance of this data vector marks, then this comes out to be 283.3684, and if you try to find out the standard deviation or standard error, whatever you call, the square root of the variance of marks comes out to be 16.83355, right. So, let me try to show you these things on the R console so that you get here more confident. So, let me try to copy this data. You can see here, this is here the data set marks, and now in case if you try to find out the variance of marks, this comes out to be here like this 283.3684, and if you try to find out the square root of this quantity, you simply have to use the function sqrt and you can obtain it here 16.83355, right. So, that is pretty simple, and if you really want to find out the variance in terms of the divisor n, then this command is going to be simply here say n minus 1 upon n into variance of marks, right. And if you want to find out the standard error, that can be simply the square root of this of the same quantity, right. So, and this is here the screenshot of the same operation, but let me try to show you these operations on the R console also, so that you get more confident that yes, these things are working. And I would like to show you here one thing here, actually here more, that the variance is like this, and if you want to find out the standard deviation or standard error, just try to take the square root of this quantity. This is coming out to be 16.40. So, you can see here that although there are two forms of this variance in the divisor 1 upon n minus 1, it is going to give you the value 283, and in the case of divisor 1 upon n, this is going to give you the value 269. That is obvious, means you are trying to divide the same quantity in both the expression by n or n minus 1, but definitely this difference will be more important when your sample size is small. In case if the sample size is extremely large, then possibly the quantity is small, n minus 1 upon n, that will become nearly the same as here 1, and it will not practically make any difference whether you are using the divisor n or n minus 1, right. So, you can see here that n minus 1 upon n, that is equal to 1 minus here 1 upon n, and if your n is going to infinity, this quantity will go to 0 and the entire quantity will go to 1. So, that will not make any much difference here, right. Okay. So, now I come back on say another aspect, that I would like to give you some idea that how are you going to compute the moments, right. In order to compute the moments, you need a special package, right. That package is not included in the base package of your R. So, for that you need a package whose name is moments, moments, and so you simply have to use the command here install dot packages, and within the parenthesis, within double quotes, you have to write moments, and after that you need to load the package by using the command library moments, right. So, now in case if you try to compute the sample moments on the basis of given set of data, then we have the same command all dot moments for computing raw moments, central moments, and some other type of moments. You can find the details in the help, but these moments are just obtained by putting different choices inside the parenthesis for the different parameters. So, we try to see here how they are going to be obtained, right. So, for example, if you try to see in this command all dot moment, there is one value inside the parenthesis, which is here x. So, x is going to be a data vector for which you want to find out the moments, right. So, this can be a numeric vector, matrix, or a data frame, right. In case if you are trying to consider the data frame or the matrices as the input data, then each column is going to work like as an random variable, and yeah, means there is a command here order dot max. So, that is going to indicate that what is the order of the movements that you want to compute, and there will be option here central, CENTRAL. This is a logical variable, and its value can be either true or false. So, this can be here true or false, and if you try to see here, if you try to understand the meaning, you are simply trying to say here central is equal to true or false. So, central is indicating the presence of central movements. So, once you are trying to say here central is equal to false, that means you do not want the central movement, that means you want the raw movement. And if you try to say here central is equal to true, that means you want the central movement. So, just by controlling this central as true and false, compute the raw and central movements, right. So, that is what I have written on this slide. Now, let me try to take the same example and we try to compute this movement, right. So, we have the same data vector on which we have just computed the variance, which is stored in the data vector here marks. So, we try to install the the package movements, and then we try to load it, and after that we try to use here two commands just to show you that if you want to find out the movements up to order 2 or the movements up to order 4, and how you have to be careful, how you have to interpret the values, right. So, suppose if I use the command here order dot max equal to 2, and we assume that we are interested in finding out the movements up to second order. Right. Now, here you have to be careful that when you say order dot max is equal to 2, then what is the starting point? The starting point is from 0 or from 1. So, whether you want to compute the first movement and second movement, or you also want to compute the 0th movement, that is mu 0 prime, right. So, in R, this starts from R equal to 0. When you say order max, then that means mu R prime R is equal to 0, 1, 2. This is how it is going to be used. You have to be careful. Many times people think that okay, this is going to give us only 2 values, or if they try to look only in the outcome, they believe that this is going to give them 3 values, which are the values of first 3 movements. So, be careful. So, in case if you try to find out the movements of this data set for order dot max equal to 2, then we use the command here all dot movements. Inside the parenthesis, I will use the command max comma order dot max is equal to 2, and the output will be like this 1 56.0 3405.2, and so this is going to give you the mu 0 prime. This is the value which is the mean value mu 1 prime, and this is the value of here mu 2 prime. And similarly, if you try to use here the option order dot max equal to 4, then you will get here the mu 0 prime, mu 1 prime, mu 2 prime, mu 3 prime, and mu 4 prime, right. So, this is the, for example, this is the value of here 1 upon say here 20, I goes from 1 to 20, and then x I raised to the power of here 4, right. So, this value will come out to be like this, right. Okay. Now, so this was about the calculation of the raw movements. Now, in case if you want to compute the central movements, I will use the same command, but I will simply make here the parameter central to be true. That is all. I will simply add here this parameter. Central is equal to 2, and all other interpretation they will remain the same. So, I use here the command all dot movements max comma order dot max equal to 2. So, this is going to give us the value of here mu 0 and then here mu 1 and then here mu 2. So, you can see here this mu 1 is coming out to be 0, because this is the value of 1 upon n summation I goes from 1 to n x I minus x bar, and right, and then n is equal to here 20, and mu 2 is the value of the same command that will come from the variance of x, right. And similarly, if you want to find out the first 4 movements, so for that you have to use the command here order dot max, where the first value will be coming out to be here the value of mu 0, then the second value will be of mu 1, third value will be of mu 2, fourth value will be of mu 3, and the last fifth value will be of here mu 5. So, in this case, this mu 5 is going to be 1 upon 20, I goes from here 1 to 20, say x I minus the value of here the mean. Now, what is the value of here mean? That you can see here, this is here 56.0, right. So, this x I minus 56 is the power of here 4. So, you can see here that this R helps you in the quick computation of these problems, right. And now, this is the screenshot of the same outcome that I have just shown you. Now, I would like to show you these outcomes on the R console, right. So, let us come back to the R console here, and we clear the screen here, Control L. So, now you can see here we already had entered the data in terms of data vector marks, and if you try to find out its movement by the command here like this, means all dot movements marks dot order dot max equal to 2. So, that will give you the movements up to the order 2, which are the raw movements. And if you try to add here central is equal to here true, then you will see here that you are getting here the central movements. So, this is your first central movement, which is always 0, and this is your here second central movement. And if you try to simply find out here the movements up to order here 4, these are here these values are the first raw movement, second raw movement, third raw movement, and this is here fourth raw movement. And if you want to find out here the first 4 central movement, then you have to simply type here say central is equal to true, and you will get here the values of central movements. Right. So, you can see here that these are not very different things, and computation of this movement is not difficult in the R software. But one thing, what are they going to indicate? That is very important. Movements are simply only the tools. For example, we have seen the interpretation of first raw movement and the second central movement, right. They are trying to depict, or they are trying to take out the important information which is not visible from the eyes, but it is hidden inside the data, and these tools are going to give you that idea. For example, the first raw movement is giving you an idea about the central tendency of the data, and second central movement, that way, which is variance, that is going to give you an idea about the spread of the data around the central value. And these are very important properties which we try to study in terms of any data set, and try to characterize it. So, for example, in this example you can see that we have found the movements up to order 4. So, the first question comes that we have now understood what is the meaning of first and second movement, what this third and fourth are trying to do, and what means higher order movements like as fifth, sixth, etc. they will try to indicate us. So, that is the topic which I am going to take in the next lecture. So, try to have a quick revision, try to take a small data set and try to find out the value of the movement manually using your own hand manual calculations, and then try to verify them in the R software also, and then be confident. So, try to practice it, and I will see you in the next lecture. Till then, goodbye.